Welcome back to the Scotti-BYTE channel, and this is Scott. So in my continuing series on the quest to understand virtualization, we are going to discuss virtual disks inside of a LXD container. In the last tutorial, virtual disks in Linux, we learned that a file can be created, formatted, and mounted as a virtual disk in a bare metal or virtual machine. In the tutorial LXD Containers Mount Host folders, we learned that the LXD host can share folders with a LXD container, and that's really the preferred method. The virtual disk capability is not easy to achieve inside of a LXD container because it relies on accessing the loop device on the LXD host and having privilege to execute mount commands. This is not generally allowed because it can potentially compromise LXD host security, and the point of LXD containers is complete isolation from the host and from other containers to maximize security. So, as on the channel before, I am exposing the LXD container to the LAN with my untagged profile. To learn about bridging in Mac VLAN with LXD, watch my video entitled Network Bridge versus Mac VLAN on LXD. So this time I'm going to create a container without actually starting it. Recall from the channel before that I would do a LXD launch, which creates the container and launches it. Here I'm doing LXC init, which actually just creates the container but doesn't actually start it. So we do a LXC init from Ubuntu image for Jammy Jellyfish, which is version 2204. We call the container test-lxd. I'm using the default profile. I'm also using the untagged profile as mentioned earlier. And then I'm setting the boot.autostart flag equal to true, which means that every time the LXD host boots, it starts this particular container. And then security.privileged equals to true, which is a requirement for our virtualized storage. And then security.syscalls.intercept.mount equals true, which gives mount capability to the container. And then security.syscalls.intercept.mount.allowed equals ext4 will allow us to have an ext4 file system mounted virtually inside of the container. And then I'm setting my memory limits on my container to be 2 gigabytes and up to a maximum overhead of 20% on the CPU. So we must add loop control and loop support for character-oriented I/O to our container. And we do that with LXC config device add to test-lxd, loop control, Unix character, and then it says the path is going to be /dev/loop control. Then we have to find a free loop device on the host to support mounting. And this is done with the LXC config device add test-lxd loop1 Unix-block where the path is equal to /dev/loop1. So in my tests, I found that loop1 was not free, neither was loop2, and actually loop3 was the first one that worked. And your mileage may vary on your system. In the demo, we're going to go through what I mean by that. So in my tests, again, loop 3 was free and it actually worked. So your loop device is going to be different. So then we want to start the LXD container with the LXC start test-lxd since it's set up correctly now. And then I do LXC exec test-lxc with the BOSH shell. And then kind of similar to what we did yesterday with the virtual disks in VM or in a bare metal machine, I'm going to do a truncate size equals 1 gigabyte /media/disk.img. What that's going to do is it's going to create a 1 gigabyte blank file over in the media directory that we're going to use as our virtual disk. Next, I'm going to do an mkfs.ext4 on /media/disk.img. And what that's going to do is it's going to format that file as an ext4 file system. And then I'm going to do a makedir on /mnt/virtual disk, which is going to create a virtual disk folder inside of the mount directory, which will be our mount point for our new virtual drive. And then I'm going to do a mount/target or type is ext4. Output is to the loop device, and then /media/disk.img, and then a space /mnt/virtual-disk, which is the mount point. And then I'm going to do a mount vertical bar, which is the pipe command, grep virtual disk, and that will verify whether or not my disk is actually mounted. So let's go try this out and see how this works. So here we are on my LXD host preparing to create my container with the LXC init command as opposed to the LXC launch command as we indicated in the video. I hit enter, it creates the LXD container, and now the container's been created. If I do a LXC list, you can see that I have some LXD virtual machines here and the one LXD container. All of my containers at this point in time are stopped. The next step is I'm going to do a LXC config device add to test.test-LXD loop control and Unix-character, where the path is going to be /dev/loop control. And that's been added to our container. And the next step is going to be the step that is perhaps a bit more complicated, and that is where we are going to try to mount or add the loop device. And initially, as I said in the video, I did a LXC config add test-LXD loop1 Unix-block path equals /dev/loop1. And although this may fail, we'll go ahead and perform this anyway. So now that we've done that, we can do a LXC start on test-LXD. That should start the container. If I do a LXC list, you can see that the container is started, running, and it has obtained an address on my main network with the untagged profile. The next step that I'm going to do is a LXC exec test-LXD and enter the BOSH shell. Now I have a root prompt on the container, and the next thing I'm going to do is create the disk image that we want to mount. And I create this disk image with a truncate. The size is 1 GB /media/disk.img. And I'm not needing to provide a sudo command simply because of the fact that I am running as root here. The next step is I'm going to format that virtual disk image file with the command mkfs.ext4 /media/disk.img, and you can see here that it formatted the 1 GB container the way we had wanted. And finally, we're going to do a makedir on /mnt/virtual-disk, which will be the mount point for our new container. So our next step is going to be mounting the virtual container with the mount with the type ext4 using the loop device on /media/disk.img, and then the mount point being /mnt/virtual-disk, which was the folder we just created as the mount point. We hit enter, and you can see that it says it failed due to not being able to set up the loop device correctly. To try and resolve this problem, we're going to exit out of my container and we're going to execute the command again, LXD config device add test-LXD, and the first time you note that I added loop 1 and Unix block and loop 1 over here again. From experience, I've discovered that when I added loop 2, I also had a failure. When I added loop 3, it was a clear and available device. So now I'm going to add loop 3, and then I'm going to go back into the shell again, and in the shell, I'm going to reattempt the mount. At this point in time, we did not get any kind of an error back from the mount, leading you to believe that it worked, but if we were on a normal Linux system, we would have received a mounted command back letting us know what happened. So to test to see whether or not our disk is really mounted, one of the things we can do is we can do a mount and pipe that over to grep for virtual disk. And here you can see that it is mounted on a device. Another way we can see that is by doing a df. And you can see that the df says that device/loop3 has virtual disk mounted. If we cd over to /mnt and /virtual disk, we're now inside of that virtual container, and we can do make dir test, and we can do a touch of this file, and we can do an ls, and you can see that we have a lost and found indicating that we're at the top level of the disk. We have a test folder, and we have a this-file. So in moving over to the media directory, if we do an ls, you can see that disk.img is the container that's holding the virtual disk that we just mounted and put a directory and a file into. I've also added an ISO image into the folder for the media, and this ISO image is an ISO image of the Ubuntu 2004 live server version. So the next step is we do a df, and we can see that on loop 3 we have mounted our virtual disk that we just added the file and directory into. So we're going to create a mount point for the server ISO image with the make dir /mnt /ubuntu-server, and the next step we're going to do is a mount command for that particular device, and we're going to do a mount /o space loop /media /ubuntu-20.04 live server, and then /mnt /ubuntu server, which was the mount point that we just created. And this should fail. And sure enough, it fails. The reason that it fails is because we only have one loop device, and that is loop 3. So if we exit back out, we should be able to do a LXD config device add to our container loop 4 Unix block path loop 4, and that should add a loop 4 device, and it added it to the container. Now we go back into the container, and this time we reattempt the mount, and the mount fails again because apparently that wasn't a free loop device. So we exit back out. We again try this with loop 5. Just keep incrementing the loop device till we find one that actually works. We go back into the container. We do the mount command again, and this time it fails once again. So I exit back out. Again, I change this to loop 6. Add it to loop 6. Again, go back into the container, reattempt the mount, and it fails again. So the long and short of this is you would think that I'd be able to get this to work, but apparently from inside a LXD container, you can only have one loop device mounted at a time, or at least that's my conclusion, because I probably created 10 different devices attached to the container with no luck. So what we're going to do here is we're going to do a U-mount on /mnt /virtual-disk, dismounting that virtual disk. And you can see here that if we do a DF again, the virtual disk is no longer mounted on loop 3. And now we'll do a mount command of the DVD. And this time it is mounted read-only. And if we do a DF, you can see that it mounted it also on loop 3. So if we CD over to /mnt/ubuntu-server, we will be on the read-only image of the DVD-ROM for Ubuntu server. We do an ls, there's the files at the top level of the Ubuntu server. So this might not be a problem overall, because if you consider the fact that I could mount the virtual disk, and then I could turn around and dismount it, and then I could mount the CD-ROM or DVD image, and I didn't have a problem. It really points to the fact that we can only use one loop device at a time, and I can't really find a reason right now overall why that might be the case. But in my tutorial, LXD Containers Mount Host folders, I point out how to access host folders that are on the LXD host from inside of a LXD container, and that's probably more functional anyway. But since we were on the course of virtual disk access, I think that this has been a productive thing to take a look at. So in summary, we were able to create a LXD container with the necessary access to the host for mounting a loop device. This is not advised in a production environment because of security concerns on the LXD host. And this technique may be helpful in accessing virtual disk images or files from an ISO image. The preferred way to access data from images would be to mount them on the LXD host, as described in my tutorial, LXD Containers Mount Host folders. This was primarily meant as a case study showing a capability not thought to be readily possible in LXD. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.